March 22, 1945, 10 p.m., Nierstein, Germany. The Rhine is silent. Dark water rushes past at 6 feet per second, 300 meters wide. Too deep to wade, too fast to swim. For 2,000 years, this river has been the wall between empire and wilderness, civilization and chaos, victory and defeat. On the western bank, combat engineers from the 249th Battalion check their watches. 18 hours. That's all they have. The enemy is 400 yards away. Artillery could open up at any moment. Spotlights would turn the river into a killing field. But General George Patton wants to beat British Field Marshal Montgomery across the Rhine, and he's given them an impossible deadline. 40 men start unloading pontoons from trucks. No cranes. No heavy machinery. Just hands, cables, and a bridge design most German engineers have never heard of. By dawn, 60,000 American vehicles will cross on a structure that doesn't exist yet. The Germans watching from the eastern hills don't believe it's possible. They're about to be proven catastrophically wrong. The problem no one could solve. In 1939, military engineers across Europe faced the same nightmare. Bridges were dying faster than they could be built. The old way of building bridges, stone pilings, concrete spans, weeks of careful construction, belonged to a different era. Modern warfare moved too fast. Retreating armies blew every crossing. Bombers turned ancient bridges into rubble. Tank columns that reached rivers without bridges simply stopped, becoming perfect targets for artillery. The Germans had been brilliant at this defensive strategy. As they fell back across France, Belgium, and finally Germany itself, Wehrmacht engineers destroyed everything behind them. Every bridge, every railway crossing, every ferry landing. They turned Europe's waterways into a network of tank traps thousands of miles long. By March 1945, the Rhine, Germany's final natural defense, had become the ultimate test. The river was swift, deep, and utterly impassable without bridges. The U.S. Army Corps of Engineers declared it unfordable even at low water. And the Germans had systematically destroyed every significant bridge across it, or wired them with enough explosives to ensure no span would survive capture. Traditional military doctrine said crossing such a river required months of preparation. Massive stockpiles of materials. Thousands of men. Complex engineering works built far from the front lines, then transported forward and assembled under the cover of overwhelming force. But General Dwight Eisenhower didn't have months. The war was entering its final phase. Soviet forces were grinding westward through Poland and East Germany. Every week of delay meant more civilian casualties, more concentration camp prisoners dying, more cities reduced to ash. Speed had become the most valuable resource on the battlefield. The British had one solution: their meticulously planned Operation Plunder, scheduled for late March. Montgomery's crossing would involve over 1 million troops, 14,000 paratroopers, months of preparation, and enough material to rival the Normandy landings. It was thorough. It was cautious. It was very British. The Americans, however, were about to demonstrate something else entirely. The bridge that could be carried in trucks. His name was Donald Bailey, and in 1940, nobody thought he was a genius. A civil servant in the British War Office. Not a specialist in bridge construction. Not a decorated officer or renowned engineer. Just a man who liked to tinker with model bridges as a hobby, who'd once sketched an idea on the back of an envelope after watching another bridge design fail during a demonstration. His idea was almost insultingly simple. Instead of building bridges from the bottom up, laboriously constructing supports, then spans, then decks, why not build them from panels? prefabricated steel sections, each one 10 feet long by 5 feet high, weighing just 600 pounds. Light enough for 6 men to carry. Small enough to fit in a standard military truck. The panels connected end to end with simple pins. No welding. No specialized tools. No engineering degree required. To make a bridge stronger, you just added more panels side by side. To make it longer, you added more end to end. Like building blocks, but made of steel that could hold a 40-ton Churchill tank. The British tested his prototype in May 1941. They loaded it with a World War I-era Mark V tank. Then added smaller tanks on top of that. Then filled the Mark V with scrap iron until the weight approached 100 tons. The bridge held. The Army immediately ordered mass production. By 1942, the Americans had seen enough to license the design and start building their own variants. By D-Day, the Allies had stockpiled thousands of Bailey Bridge panels across England, ready for the invasion of France. Over 600 firms became involved in production. More than 200 miles of bridging, 700,000 panels, rolled off assembly lines during the war. But having the equipment was one thing. Using it under fire was something else entirely. March 7, 1945, 3:15 p.m., Remagen, Germany. Lieutenant Karl Timmermann stared at something impossible. The Ludendorff Bridge, 1,000 feet of steel and stone spanning the Rhine at Remagen, was still standing. His reconnaissance unit had expected rubble. Every other bridge within 100 miles had been destroyed by German engineers. The orders were clear. If they found bridges, they'd find craters. But here, in front of 120 exhausted American infantrymen, stood an intact crossing into the heart of Germany. Timmerman could see German engineers on the far side, frantically working around the bridge towers. They'd wired the structure with 2,800 kilograms of demolition charges. He watched them run toward the detonation control panel. Then the western span erupted. The explosion damaged the approach ramp, making it temporarily impassable for tanks. Timmerman knew he had seconds. He rushed the bridge with his infantry, feet pounding on steel and wood. The Germans tried to blow the central span. The charges failed. They tried again. The bridge seemed to lift into the air, then settled back down on its foundations. In their haste, German engineers had placed a detonator incorrectly. And those Russian prisoners of war who'd built the bridge during World War I had built it too well. The French, during their occupation, had filled the original demolition chambers with concrete, making the structure nearly impossible to destroy. Sergeant Alexander Drobick became the first American to reach the eastern bank of the Rhine. The news reached Supreme Commander Eisenhower within hours. Front-page headlines across America. Soldiers crossing the Rhine on foot, with tanks and trucks following. The traditional defensive barrier to Germany's heart had been pierced. But the Ludendorff Bridge was damaged. Weakened by the failed demolition, by months of Allied bombing runs, by the structural stress of thousands of troops and vehicles crossing in both directions. The Germans threw everything at it: artillery, floating mines, even V-2 rockets. On March 17th, at 3 p.m., the bridge collapsed into the Rhine. 28 American engineers died. 93 were injured. By then, it didn't matter, because in the 10 days since its capture, American combat engineers had built 3 complete replacement bridges right next to the ruins. The speed that terrified an empire. The statistics seem impossible until you see them repeated over and over across multiple rivers, multiple countries, under fire from multiple armies. The 249th Engineer Battalion built a 1,000-foot pontoon bridge across the Rhine at Nierstein in 18 hours, while being shot at in the dark across a river falling so rapidly that anchor calculations had to be constantly revised. 18 hours. At Carentan, engineers spanned the Dove River with a Bailey Bridge in 18 hours under German artillery fire. The Kinkanal and Orne River, bridged on D-Day itself, while under fire from every German gun within range, by engineers who had rehearsed the operation so many times in Scotland that they could assemble the components in complete darkness. The average construction time for Bailey bridges during the entire European campaign, 24 hours. Compare that to traditional bridge construction. Weeks, sometimes months. The Ludendorff Bridge at Remagen had taken 3 years to build during World War I. The Brooklyn Bridge took 14 years. Modern engineers estimate that building a permanent bridge across a 300-meter river requires a minimum of 18 months. The Americans were doing it in less than a day. And not just once. Engineers were averaging 2 Bailey bridges per day by the end of 1943. Over 700 Bailey bridges had been erected across Europe by 1945. At least 2,500 more were built in Italy. 16 floating Bailey bridges crossed the Rhine alone, with an average length of well over 1,000 feet, erected at a rate of 90 feet per hour. For the Germans, this was incomprehensible. Wehrmacht doctrine assumed that losing bridges meant stopping enemy advances for weeks. Time to regroup. Time to establish new defensive positions. Time to bring up reinforcements. Their entire strategy of defense in depth relied on destroying infrastructure faster than the Allies could replace it. But the infrastructure was being replaced overnight. German prisoners of war, interrogated after the Rhine crossings, expressed genuine confusion. They'd been told that destroying the bridges would halt the American advance. They'd watched their own engineers spend days, sometimes weeks, preparing demolitions and building defensive positions around bridge sites. Then American engineers showed up and built new bridges faster than German forces could organize effective counterattacks. The method behind the speed. Watch footage of a Bailey Bridge being constructed, and the operation looks almost casual. No cranes lifting massive sections into place. No engineers shouting calculations over the roar of heavy machinery. Just men in helmets, working with wrenches and pins, sliding steel panels into position as if assembling furniture. But the simplicity is deceptive. Every bridge begins on shore, assembled section by section on special rollers that are part of the standard equipment kit. 10-foot panels connect end-to-end with pins. Simple. Fast. No welding required. As each section is completed, the entire growing structure is pushed forward on the rollers, extending out over the water. A false nose, a temporary extension, is attached to the leading edge. This nose reaches across the gap first, acting as a cantilevered support. Once the nose touches the far bank, workers can complete the final panels, then remove both the nose and the rollers. The bridge locks into position on simple supports. The entire system uses just 17 types of parts for the bridge itself, plus 9 more for the supports. Nothing requires specialized tools. A trained engineer team could assemble the components while half asleep, which is good because they often were. Combat engineers worked in shifts around the clock. One group positioned pontoons. Another laid decking. A third secured anchor cables to prevent the bridge from drifting in the current. Teams rotated every few hours, snatching sleep in foxholes or the backs of trucks. And they did this under fire. German artillery knew where bridge construction sites would be, at the narrowest, most practical crossing points. Mortars ranged in on the obvious assembly areas. Snipers targeted officers and anyone who looked like they might be in command. The Luftwaffe, though depleted by 1945, still sent jets screaming down the Rhine Valley, dropping bombs on any bridge they could reach. Engineers died by the dozens. Explosions in the water sent shockwaves that could rupture organs. Sniper fire was constant. Artillery shells created geysers that swamped pontoons and pulled men under. But the bridges kept growing. Because for every engineer who fell, 2 more stepped forward to take their place. Because the modular design meant that individual sections could be replaced without rebuilding the entire span. Because American industrial capacity had produced so many panels, so many pontoons, so much bridging equipment that losses could be immediately replaced from stockpiles. The Germans had nothing equivalent. Their pontoon bridges were functional, but required far more time and specialized equipment. Their combat engineers were skilled, but they lacked the modularity, the mass production, the sheer overwhelming industrial backing that let American units treat bridges as disposable. At the Remagen bridgehead, American engineers built 3 bridges, while German forces tried desperately to destroy one. By the time the Ludendorff finally collapsed, pontoon bridges were already carrying the main traffic. When those were threatened, treadweight bridges went up. When those needed reinforcement, Bailey bridges were constructed alongside them. The Americans weren't just replacing bridges. They were outbuilding the capacity of German forces to destroy them. The night Patton crossed the Rhine, General George Patton was obsessed with one thing: being first. Not first across any bridge, first across the Rhine ahead of Montgomery. The careful, methodical British Field Marshal had been planning Operation Plunder for months, a massive, set-piece assault involving overwhelming force and meticulous preparation. It was scheduled for March 23rd. Patton intended to cross on March 22nd. His Third Army approached the Rhine near Oppenheim, south of Mainz, on the night of March 22nd. No artillery preparation. No preliminary bombardment to alert the Germans. Just infantry and assault boats, crossing in darkness. They caught German troops completely by surprise. Within hours, 4 American divisions had secured the eastern bank. By dawn on March 23rd, combat engineers were already constructing bridges. The 249th Engineer Battalion received their orders: build a pontoon bridge at Nierstein, 6 miles from Patton's crossing point, 1,000 feet across rapidly falling water, under potential enemy observation from hills on both sides. Estimated construction time using traditional methods: 3 days. They had until morning. The battalion used a lottery system to select who would make the first crossings, a recognition that the initial waves faced almost certain death if the Germans counterattacked. No one volunteered. No dramatic movie speeches. Just 19-year-old kids drawing lots in the darkness. Robert Shilato, a combat engineer from Indiana, was one of them. It was thrilling, he recalled 72 years later, as a 19-year-old kid with the enemy only 400 yards away. The engineers loaded pontoons onto amphibious craft and crossed the river under a clear moonlit sky. Every man expected German spotlights to blaze on it any second, turning the Rhine into an illuminated shooting gallery. Every moment expected the shriek of incoming artillery. But the crossing was quiet. The Germans, disorganized and depleted, failed to mount an effective response. American engineers landed on the eastern bank and began anchoring the first pontoons. More engineers followed, bringing sections of bridge decking, cables, tools. They worked in near silence, afraid that noise would draw fire. Section by section, the bridge grew. By dawn, the structure stretched 1,000 feet across the Rhine, 366 meters of floating roadway, capable of carrying tanks, trucks, artillery pieces. Construction time, 18 hours. Patton himself crossed the following day. Halfway across the bridge, he stopped his jeep, climbed out, and, in full view of his officers and any German observers with binoculars, urinated into the Rhine. "I've been looking forward to this for a long time," he said. It was crude. It was theatrical. It was pure Patton. And it was symbolic of what had just happened. The Americans had crossed Germany's final barrier not with overwhelming force, but with speed and engineering that the Germans couldn't match. What the Germans saw. Imagine being a German soldier on the eastern bank of the Rhine in March 1945. You spent weeks preparing defenses. Your engineers have assured you that once the bridges are destroyed, the Americans will need weeks, maybe months, to construct replacements. The Rhine is too wide, too fast, too deep for anything but a major engineering operation. Then you watch American troops cross in boats. That's concerning, but containable. Infantry without armor can be pushed back. The real threat is tanks, and tanks need bridges. So you wait for the Americans to begin their lengthy bridge construction. Days of work. Engineers moving materials to the riverbank. Heavy equipment. Complex preparations. Instead, within hours, you see sections of bridge appearing out of the darkness. By morning, there's a complete span across the Rhine. Trucks are already rolling across. By afternoon, tanks follow. By evening, the Americans have established supply dumps on your side of the river, and their engineers are already constructing a second bridge. You've been trained that destroying bridges creates strategic delays measured in weeks. But the Americans are replacing bridges in less than 24 hours. Faster than your remaining artillery can effectively target them. Faster than your disrupted chain of command can organize counterattacks. It's a fundamental breakdown of military logic. The Wehrmacht had based its entire defensive strategy on the assumption that modern armies move at a certain maximum speed. That industrial warfare requires long supply chains, careful logistics, time to consolidate gains. That geography still matters in an age of tanks and aircraft. But here were Americans treating the Rhine, one of Europe's greatest rivers, as barely more than an inconvenience. German military reports from late March 1945 reflect a sort of exhausted bewilderment. Officers noted the remarkable speed of American bridge construction. Interrogations of captured American engineers produced information about the Bailey Bridge design, but by then, it was far too late to develop countermeasures or equivalent systems. The psychological impact was perhaps even more significant than the tactical. For German troops who'd been promised that the Reich's natural borders would slow the Allied advance, watching bridges appear overnight was devastating. It suggested an enemy with unlimited resources, unstoppable momentum, and engineering capabilities that seemed almost supernatural. Some German engineers, after the war, expressed professional respect bordering on disbelief. The Bailey Bridge system represented a paradigm shift in military engineering, a recognition that in modern warfare, temporary infrastructure could be more valuable than permanent construction. But respect came later. In March 1945, what German forces felt was something closer to despair. The cost written in water and steel. The bridge at Remagen collapsed at 3 p.m. on March 17. 28 engineers were on the structure when it went down. Most died instantly, crushed by falling steel or drowned in the swift current. 18 bodies were never recovered, presumably swept downstream and lost in the Rhine. 93 others were injured in the collapse. Broken bones, crush injuries, hypothermia from the icy water. These men were working to repair the damaged bridge while combat raged around them. German jets screamed overhead. Artillery shells splashed in the water. V-2 rockets, Hitler's wonder weapons, slammed into the riverbank in desperate attempts to destroy the crossing. The engineers kept working anyway. because they knew that every hour the Ludendorff Bridge remained standing meant thousands more American troops could cross into Germany. Every delay they prevented potentially shortened the war by days. Every tank that crossed on their repairs would save infantry lives in the fighting ahead. The statistics across the entire European campaign are sobering. U.S. Army combat engineers suffered some of the highest casualty rates of any non-infantry unit. They led advances, clearing mines and obstacles. They worked in the open, exposed to fire, while constructing bridges and roads. They stayed behind when combat units moved forward, maintaining supply lines under constant artillery bombardment. At the Caen Canal on D-Day, engineers bridged the crossing while under fire from every German weapon within range. Several were killed before the first span was complete. The survivors finished the job, then moved on to the next river. In the forests of the Ardennes during the Battle of the Bulge, the 249th Engineer Battalion fought as infantry when German forces broke through American lines. They laid minefields, established roadblocks, and held defensive positions, missions they'd never trained for, because there was no one else available. Combat engineers were supposed to build things. Instead, they often found themselves in situations where survival depended on stopping enemy advances long enough for actual combat units to arrive. But they're remembered for the bridges, the momentum that crushed an empire. By the end of March 1945, all four American armies fighting in Western Europe were east of the Rhine. The 1st and 9th Armies encircled the Ruhr industrial region, Germany's industrial heartland, trapping over 300,000 Wehrmacht troops in a pocket that would collapse within weeks. The 3rd and 7th Armies pushed east into central and southern Germany, moving so fast that German units couldn't establish coherent defensive lines. And the bridges kept multiplying. 16 floating Bailey bridges across the Rhine. Dozens more across smaller rivers. Hundreds of pontoon crossings. The Americans weren't just crossing obstacles. They were creating an infrastructure network in real time, building supply lines as the armies advanced. German forces, already battered and undersupplied, couldn't cope with this tempo. Traditional military doctrine said armies need time to consolidate after major river crossings, time to establish secure bridgeheads, time to build up supplies and reinforcements before pushing forward again. The Americans barely paused. Bridges went up within hours of securing the western bank. Supply convoys crossed while combat engineers were still installing final decking sections. Tank columns moved east almost immediately, exploiting breakthroughs before German forces could seal them. This was warfare at a pace the Wehrmacht couldn't match. Not because German soldiers were less courageous or skilled, they were fighting with desperate ferocity, knowing their homeland was being invaded, but because the fundamental infrastructure of modern war had shifted beneath them. Armies move on bridges. Bridges require engineers. Engineers require equipment, training, and most importantly, a system that allows rapid deployment of that equipment. The Germans had engineers and equipment. What they lacked was the system. The modular, mass-produced, rapidly deployable infrastructure that allowed American forces to treat bridges as disposable resources. The industrial capacity that could replace losses faster than combat consumed them. The logistical networks that kept supplies flowing to construction sites even as those sites moved deeper into enemy territory. And they lacked time. By early April, American forces had crossed the Elbe River, deeper into Germany than any Western army since the Napoleonic Wars. By late April, American and Soviet forces met at the Elbe, cutting Germany in two. On May 8th, Germany surrendered. The war in Europe was over. The blueprint that rebuilt the world. Field Marshal Bernard Montgomery, commander of British forces, was not a man given to exaggeration. Bailey bridging made an immense contribution towards ending World War II, he said after the war. I could never have maintained the speed and tempo of forward movement without large supplies of Bailey bridging. Without the Bailey Bridge, we should not have won the war. That's the professional assessment of one of the war's most careful, methodical commanders. The Bailey Bridge became the standard for post-war military engineering. NATO standardized around variants of the design, ensuring that member nations could work together seamlessly. American engineers used Bailey bridges in Korea, Vietnam, and every subsequent conflict. Modern military bridging systems all trace their conceptual ancestry back to Donald Bailey's sketches on that envelope in 1940. But the legacy extends beyond military applications. In 1975, when the Tasman Bridge in Hobart, Australia collapsed, engineers erected a Bailey Bridge as a temporary replacement. It was 788 meters long, the longest Bailey Bridge ever constructed at that time, and remained in service for 2 years while permanent repairs were completed. When earthquake struck Kashmir in 2005, the British government supplied 30 Bailey-type bridges as emergency relief. When floods devastated communities in India, engineers erected footbridges using Bailey designs to restore access within days. The U.S. Army Corps of Engineers still uses Bailey-type bridges for emergency replacements, including on the Hana Highway in Hawaii, where environmental conditions and remote locations make traditional construction impractical. Because the fundamental insight that made the Bailey Bridge revolutionary in 1941 remains true today, in crisis situations, rapid deployment matters more than permanence. Better to have a temporary bridge in 18 hours than a permanent bridge in 18 months. Better to keep moving than to wait for perfect solutions. Better to build it simple than to build it slow. The monument on the riverbank. On March 25, 2017, officials from the United States and Germany gathered on the bank of the Rhine at Nierstein. They unveiled a memorial, a 2.3-ton granite block with copper plaques, standing at the exact spot where the 249th Engineer Battalion landed on that moonlit night in March 1945. Robert Shilato was there, 92 years old, one of the last surviving engineers who'd built that bridge in 18 hours while German forces watched from 400 yards away. He stood beside Helen Patton, granddaughter of General George Patton, and Catherine Rommel, granddaughter of Field Marshal Erwin Rommel, 3 generations removed from the war that had made their grandparents enemies. The monument is not only a testimonial to the 249th Engineer Battalion, said Jerry McCarthy, president of the Veterans Association. It's about people from 2 different parts of the world, separated by thousands of miles, working together harmoniously. He was talking about the collaboration between American and German officials to fund and build the memorial. But he could have been talking about engineering itself. Because the bridge at Nierstein, like all those hundreds of Bailey bridges, like the pontoon crossings at Remagen and Oppenheim and a dozen other sites, wasn't just about crossing rivers. It was about the idea that human ingenuity can overcome obstacles faster than human conflict can create them. That temporary solutions, rapidly deployed, can be more valuable than permanent structures, slowly built. That in the calculus of modern war, speed of construction matters as much as size of armies. The plaques on the Nierstein Memorial are inscribed in both English and German. They describe the 18-hour construction, the 60,000 vehicles that crossed in the following weeks, the contribution to shortening the war. But they don't mention the most important part. The German engineers watching from the hills in March 1945 didn't just see a bridge appearing overnight. They saw the future of warfare, and realized they were on the wrong side of it. The river still flows. The Rhine at Nierstein looks peaceful now. Pleasure boats pass where pontoons floated. Bicycle paths line banks that once echoed with artillery. The anchors from the original bridge are still visible, embedded in the riverbank behind the memorial, rusting slowly into history. There's no bridge here today. The nearest crossing is 44 kilometers away. Local officials have proposed building a pedestrian suspension bridge, a permanent structure, properly engineered, built to last generations. It's been under discussion for years. In contrast, in March 1945, engineers built a 1,000-foot bridge in 18 hours. That's the paradox at the heart of this story. In peacetime, with unlimited resources and careful planning, we struggle to build bridges that once appeared overnight. We debate, we study, we allocate budgets across fiscal years. Infrastructure projects measure timelines in decades. But in 1945, with the world on fire and young men dying by the thousands every day, engineers threw bridges across Europe's greatest rivers faster than armies could march across them. The difference wasn't technology. The Bailey Bridge, for all its brilliance, was fundamentally simple: steel panels and pins. The difference wasn't skill. The difference wasn't even courage, though courage was required in abundance. The difference was urgency. When failure meant soldiers dying. When delay meant prolonging a war that had already killed millions. When every hour mattered and every shortcut was worth the risk. That urgency created systems, training, and mindsets that treated impossible as merely difficult. That urgency built 700 bridges where German engineers expected none. That urgency crossed the Rhine in 18 hours when conventional wisdom said 18 months. The last bridge. Stand at the Remagen Bridge Museum today, and you can see the towers that once anchored the Ludendorff Bridge. The western towers have been converted into a museum. Photos of the bridge before capture. News clippings from March 1945. A video documentary playing on loop, showing grainy footage of soldiers crossing, engineers working, tanks rolling. The eastern towers are now a performing arts space. Where Wehrmacht troops once manned machine guns, audiences now watch theatrical performances. Where Hitler's forces made their desperate last stand, children take music lessons. It's a transformation that would have seemed unimaginable in March 1945. But then, so would everything that happened in those 10 days after Lieutenant Timmerman led his infantry across the damaged span. The capture of one bridge. The construction of 3 replacements. The bridgehead that allowed 125,000 troops to cross the Rhine 2 weeks ahead of schedule. The momentum that turned Germany's final natural barrier into just another river. Field Marshal Montgomery's carefully planned Operation Plunder went ahead, as scheduled on March 23, still the largest amphibious operation since D-Day, still an impressive feat of military coordination. But by then, 5 American divisions were already miles east of the Rhine, spreading out into Germany's industrial heartland, and combat engineers were building bridges at a pace that had rendered the river itself strategically irrelevant. German prisoners, marched westward across those same bridges, saw firsthand the infrastructure that had defeated them. American supply trucks heading east. Pontoon bridges. Bailey bridges. Treadway bridges. Engineers working on reinforcements. Engineers working on repairs. Engineers already building the next crossing before the previous one was even finished. This was the machine that had crushed the Wehrmacht. Not superior tanks, though American tanks were good. Not superior aircraft, though Allied air superiority was overwhelming. Not even superior tactics, though American doctrine emphasized speed and flexibility. But superior infrastructure, superior logistics, superior engineering, the ability to move armies across obstacles faster than enemies could create those obstacles, the ability to replace bridges faster than artillery could destroy them, the ability to treat the Rhine River, one of Europe's greatest natural barriers, as an 18-hour inconvenience. What they couldn't believe. There's a reason this story resonates. It's not just about bridges or engineering or military history. It's about the moment when one side realizes the rules have fundamentally changed. German engineers in March 1945 understood bridge construction. They'd built some of the finest bridges in Europe. They knew how long it took to span a major river. They knew the resources required, the planning, the coordination. What they couldn't comprehend was a system that had optimized away all the complexity. 6 men carrying a panel. 40 men building a bridge. 18 hours crossing the Rhine. 2 bridges per day, day after day, across France and Belgium and Germany. An industrial capacity so vast that bridges became disposable. This wasn't a failure of German engineering. It was a failure of imagination. The Wehrmacht's doctrine assumed that infrastructure was strategic, valuable, difficult to replace, worth defending or destroying. The Americans demonstrated that infrastructure could be tactical, temporary, rapidly deployed, constantly renewed. That shift changed everything. It changed how armies moved. It changed what rivers meant. It changed the pace of operations from weeks to hours. And it ended the war in Europe months before it might have otherwise concluded. 28 engineers died when the Ludendorff Bridge collapsed on March 17. Thousands more died building bridges across Europe. Their names are inscribed on memorials, listed in unit histories, remembered by families and veterans associations. But their legacy is written in steel and water. In every military bridge design that traces ancestry back to Donald Bailey's sketches. In every emergency bridge erected after disasters. In every NATO standardization that allows Allied engineers to work together seamlessly. In the fundamental understanding that in modern warfare, in modern crisis, speed of deployment can matter more than perfection of design. The Germans couldn't believe how quickly Americans built bridges under fire. By the time they understood what they were seeing, the war was already over.